let's start the class. So, good afternoon, guys. Welcome to NEET World Institute and the NEET World YouTube channel. So, yes, this particular series is for EAPCET aspirant who are going to write the exam of upcoming EAPCET, that is 2026, right? So, till now we were discussing the topic system of particles and rotational motion, right? Now, so in this session, we are going to continue the topic where we left in the last class. Okay, so let's wait for 1 or 2 minutes. Like the people are joining over here. Okay, let's wait for 1 or 2 minutes. Wait. Yeah. Can we start the class? Excuse me. Okay, so let's start the class, right? Yes, we were discussing the topic in last class, that is, yeah, moment of inertia. We need to start. So torque has been completed, right? No, torque completed. The next topic is moment of inertia. Okay, so let's continue with the topic, right? So moment of inertia. What is the moment of inertia means? So it is the measure of the resistance of a body. Like inertia we have discussed, right? Inertia, okay, resistance of something, right? So it's a measure of resistance of a body to angular acceleration about a given axis. Okay, so if I am considering a system which is rotating around a axis, given axis, so if I talk about a system, particles will be there. So n number of particles present in the system, right? Now, so each particle will be having a different masses, right? So this, if I consider this particle m1 and this particle mn, okay, m1 from the axis, there is the distance is r1, mn, the distance is from the axis is rn. Okay, when I talk about on the axis, the particles are in the axis, the distance will be 0, moment of inertia also will be 0. Okay, that one we need to understand. So when I talk about the moment of inertia, right, so m1 r1 square plus m2 r2 square plus up to mn rn square, right? So we can write in simple term, it is I is equals to summation m r square. Okay, so the dimensional formula is mass is kg and r is meter square. So kg meter square is the SI unit and dimensional formula is ml square, ml square. So if they mention it is t power 0, yes, it's absolutely correct. ml square t power 0 is the dimensional formula and SI unit is kg meter square. Now, moment of inertia depends on mass of a body. Yes, if mass is less, moment of inertia also less. Mass is more, moment of inertia also more. Shape, yes, shape and size of the body. Then distribution of mass about the axis of rotation, how it has been distributed. Okay, then the position and the orientation of the axis of rotation. The axis of rotation also plays a major role when we are talking about moment of inertia, right? So this is the basic idea about what is moment of inertia, and this is the formula. Okay. One more important point is note point. When particle is at axis of rotation, moment of inertia will be zero, right? Yes. Mass into r is 0, r square, no, r 0. So mass into 0, it is 0. So moment of inertia will be 0, right? So this is the thing about moment of inertia. Next one, rotational kinetic energy. We know that kinetic energy, right? Normal kinetic energy, it is translation, right? No, it is nothing but of mv square, when we are talking about rotational, no, so consider a body rotating about a fixed axis. So the kinetic energy of a motion of a particle will be, so we know that this is initial kinetic energy will be of mi square. So I can write in terms of omega into r, right? Omega into r. Okay. V is equals to r omega, A is equals to r alpha. Right now, the relation between, this is the relation between linear velocity and angular velocity. This is the relation between linear acceleration and angular acceleration. Right now, so half m into omega r the whole square. So when I talk about this thing, I can expand, no, 1 by 2 m r square omega square. Right? So what is this mr square? It is moment of inertia. Half into I omega square. Okay, so this is the formula. Half I omega square is the kinetic energy in rotational motion. Okay, kinetic energy in rotational motion. Half mv square is the kinetic energy in translation. Okay, when we are talking about translational rotation, no, simple difference. Mass here, moment of inertia. Velocity, angular velocity. Acceleration, angular acceleration. Force, torque. Okay, force will be torque. The comparison, if you know that, it will be easy. Like whatever we have studied in linear, rotational will be straightforward. Okay? Yes. Sir, can you please give tips to memorize topic and formulas? Yes, we will provide the tips also. Okay, no need to worry about that. See, whenever we are studying something, no, like study the formula, like read the formula and try to apply in some questions. Okay, then you can able to do that question means, okay, fine, that's good enough. Okay, otherwise listen to the class, like we will solve the questions. Okay, so by solving, no, you will understand that where to apply that formula, how to apply that formula. The major thing people are finding difficult is when formulas are known, but where to apply, how to apply is the major thing. Okay, if you know that, it's absolutely easy to crack the exam. Okay. Yeah. So moment of inertia, right? mr square. That comparison with, yeah, kinetic energy and the moment of inertia thing. Okay. Now, like we need to know the moment of inertia of the different kinds of shape. See, derivations will do it, but we need to understand the formulas. Like I will give a sheet of the formula. We'll try to memorize that. Okay, no need to derive anything. We'll memorize that formula. Like if ring is given, what is the moment of inertia? If rod is given, what is the moment of inertia? Okay, right. We'll see that one. Okay. Yeah, this is the thing. So moment of inertia of some regular shaped bodies about specific axis. So when we are talking about moment of inertia, we need to talk about the axis of also, whether it is passing through the diameter or passing through the tangent, or when I'm talking about the rod, it is at the one end or it is at the middle of that, everything we need to talk, right? Okay, so thin circular ring, so radius will be r, and axis, if you see, axis perpendicular to the plane at the center. So perpendicular means this is plane, like this is my plane, perpendicular to the plane, in the sense it will pass like this. Okay, so formula is mr square. Okay, thin circular ring of radius r. Now the thing is diameter. So if you consider any diameter, it is mr square by 2. Okay, mr square by 2. Then thin rod length, L is given. Okay, perpendicular to rod at the midpoint. At the midpoint. So ml square by 12. And when I talk about the circular disc, thing is same thin rod length L perpendicular to the rod at one end. Okay, one end in the sense formula is ml square by 3. Okay, ml square by 3. Circular disc of a radius r perpendicular to the disc. Okay, mr square by 2. Okay, so these are the basic things. So we will, like, I will provide a sheet of a thing. Okay, so no need to worry, guys. Like whoever watching also will provide the sheet in the X, like PDF file in the chat box. Okay, no need to worry about that. Okay, you can take a note of this. Done? Can we go for the next one? Okay. So next one is circular disc. Axis is diameter. So formula is mr square by 4. When we talk about hollow cylinder, axis of the cylinder, formula is mr square. So solid cylinder, axis of cylinder. Okay, solid and hollow. What is the thing difference? Like hollow in the sense, like in the middle nothing will be there. Like it's totally solid. Okay, so it is mr square by 2. When we talk about a solid sphere of a diameter, axis of what is diameter, 2 by 5 mr square. Okay, 2 by 5 mr square. This is the some other formulas. You can take a note of this also. Done? Can we go for the next one? Okay. Fine. So we will see some theorem, like theorem of perpendicular axis, theorem of parallel axis. Okay. So the formula is moment of inertia in z-axis will be equals to sum of moment of inertia in x-axis plus y-axis. Okay, so where ix and iy are the moment of inertia of two perpendicular axes. Okay, two perpendicular axes. Okay, so this is the formula for the first thing, like perpendicular axis theorem. Second one, parallel axis theorem. Like moment of inertia of z dash will be equals to moment of inertia of z plus ma square. What is a? Is nothing but if I am finding some, like I am having some moment of inertia of the system, okay, which is passing like this. Now I need to find somewhere else which is parallel to the other axis. Okay, so the distance between two parallel axes is called as a. Okay, so formula is Iz dash will be equals to Iz plus ma square. So this is new moment of inertia and this is given moment of inertia of the system. Okay, this is the parallel axis theorem. Okay, now we will see some here for the perpendicular axis. Okay, so what is the moment of inertia of a disc about one of its diameter? One of its diameter. Suppose, yes, we know that Iz will be equals to mr square by 2. So where m is the mass of the disc, r is the radius, right? No. So Iz will be equals to Ix plus Iy. When we talk about symmetry of the moment of inertia of a disc is same about any diameter. So Ix and Iy will be same. So if I substitute the value 2 times, no, yes. So Ix and Iy will be equal. So I can say Ix plus Ix, right? No, 2Ix. So Iz will be equals to 2Ix. So Iz by 2 will be equals to Ix, right? No. So we know that mr square by 2 divided by 2 is nothing but mr square by 4. So this is moment of inertia of the disc about any of its diameter. Fine? Yes. Now this is the question. So what is the moment of inertia of a rod of a mass m, length L about an axis perpendicular to its one end? Okay, this is for parallel axis. Suppose, yes, we know that axis passing through center is given as ml square by 12. What is this one they are asking? Okay, can you give answer for this question? Yes, fast. Okay, done? Done. Okay, let's see the answer. Okay, so simple thing. So m L square by 12 is the moment of inertia that axis passing through center. Axis passing through center, right? Now when I talk about other end, no, so I dash will be equals to m given moment of inertia ml square by 12 plus m into a. What is a? The distance between the two parallel axes. Suppose if this is my L, if this is L, this one will be L by 2. So ml square by 12 plus m into L by 2. Right now? Fine. Yes. So yeah. Sorry. Yeah. So this one will be a square, right? Sorry, a square. Now what we should do now? So this is ml square by 12 plus ml square by 4. So can I multiply 3 by 3 so that denominator will be same. Ml square by ml square plus 3 ml square by 12, which is nothing but 4 ml square by 12. 1 times 3 times, so ml square by 3. So this is how we will do the sum whenever they are giving the parallel axis. Okay, so this is the answer, ml square by 3. Done? Okay. Fine. So, yeah. So this is the question. What is the moment of inertia of a ring about a tangent to the circle of a ring? Okay. Can you give answer for this question? What is the answer for this question? Yes. 30 seconds left. Fast. Okay. So when we are talking about a tangent to the ring is the plane of a ring is parallel to one of its diameter. Right now. So when I talk about a diameter and the tangent, no, I can take it's a parallel. So the distance between them will be r. So I can say A is equals to r. Right now, the distance between the two parallel axes is r. The radius of the ring. Okay. So moment of inertia of tangent will be equals to moment of inertia of a diameter plus mr square. So diameter, no, it is mr square by 2 plus mr square. So mr square by 2 plus 2mr square by 2, which is nothing but 3 by 2 mr square. So when I talk about a tangent, the moment of inertia will be 3 by 2 mr square. Okay? Okay guys. So with this I'll end the class. Okay? We'll see some more topics in the upcoming session. Okay? Thank you guys. We'll meet in the next class. Bye bye.